All right, so we're still doing exponential growth or decay. So PE to the RT equals A. It says the number of bacteria in a certain population increases according to an exponential growth model with a growth rate of 6% per hour. How many hours does it take for the size of the sample population to double? If my sample population is P, what is my end amount going to be?
P.
2P, exactly. It's going to double. So, P is my initial amount. E, my rate is 6%. My time is what I'm looking for. And my final amount is 2P. What do you think the first thing I should do with that is? Divide by P. Just like when we had a number in front, we divided by the number in front. We're going to divide by the P, which conveniently cancels the P's out of there. So we get e to the 0.06t equals 2. Since it's base E, we should then we want to get our variable out of our exponent and we have a base E, we should do what to both sides? Not the log, but the natural log, right? Since it's base E. So we're going to take the natural log of both sides. Natural log of E to the 0.06t equals the natural log of 2. We do that so that we can then move our exponent out in front. So 0.06t times the natural log of E equals the natural log of 2. The natural log of E is equal to 1, so we can basically get rid of that because 1 times anything gives us that same thing. And then we can solve it for t by dividing. So t is going to equal the natural log of 2 divided by 0.06. Punch it into our calculator and round to the nearest hundredth, it says. $11.55. It's going to take me 11.55, just a little over 11 and a half hours for my population to double. Number 17 then. Suppose that $2,900 is initially invested in an account at a fixed interest rate compounded continuously. Suppose also that after 2.5 years, the amount of money in the account is $3,126. Find the interest rate per year. So compounded continuously tells me I have to use that formula there, where I'm using base E. So P would be equal to the P would be what number? 2,900. E to the, we're finding the rate. The time is 2.5, so I'm going to use 2.5 just because it's easier to use on my calculator. And I'm going to end up with my final amount being 3,126. So first thing I want to do with that is divide. That one doesn't cancel anything out very easily, so I'm just going to leave it like that since I'm using my calculator anyway. I'm then going to do what?
The natural log.
Take the natural log of both sides so I can move my exponent out in front. So this would be 2.5r times the natural log of e equals the natural log of that weird fraction. We can then natural log of e is equal to 1, so we can basically get rid of that. And in order to solve that for r, then we're going to take the natural log of our 3,126 over 2,900 divided by our 2.5, right? And we are rounding my percentage to the nearest hundredth. So first of all, what are we getting on our calculator?
0.03.
I'm going to carry it out just a little farther because we have a decimal number. We want it as a percent, so we still need to change it to a percent and then round it off to the nearest hundredth. So if I change it to a percent, I'm going to have 3.00. Since there's a 1 behind that, I don't have to round it up. But again, since it says round to the nearest hundredth, they're probably going to show to the hundredth spot instead of just saying 3%. And the last one here in the logarithm section. The number of bacteria in a certain population increases to an exponential growth model with a growth rate of 3.5% per hour. How many hours does it take for the size of the sample to double? So this should be pretty close to number 16, right? What should I set up for my equation? So I'm going to use point 0.035, right? 3.5% is 0.035. Times t equals 2p. So we're going to start by doing what? Dividing by our p. E to the 0.035t equals 2. We are then going to take the natural log so we can move our exponent out in front. So 0.035t times the natural log of e equals the natural log of 2. We can then cancel out our natural log of e since it's equal to 1. And so to solve that for t, what are we going to do? So we're going to take the natural log of 2 divided by 0.035. And we're going to round our answer to the nearest hundredth, it says. So they're gonna put 19.80, so we showed that we rounded it to the nearest hundredth, even though it's a zero there. All right.